So tell me what you want.
Hi, everyone. Thank you for joining today's meetup. And today we have a guest speaker, Bharath. He will present some topic related to laser beam scanning for augmented reality and near to eye display applications. So yeah, I will pass the baton to Bharath. Yeah, thank you.
Okay, great. Thanks, Dominic, and thank you all for joining. So let me go ahead and start to share my screen. Just give me a second here. We use so many platforms these days, right? I typically use Microsoft Teams quite a bit. So let's see. Okay, here we go. And all righty, give me 1 second, folks. I will be there. There we go. Share screen, and there we go. And hopefully it'll work. Let me know once you can see this, Dom.
Yes, we can see it.
Can you see my screen?
Yes.
Okay, great. So broad topic, right? A lot of things to cover here. You know, it'll probably take a full day of discussion. It's just a discussion we had before the meeting started with some of the folks here. Some really interesting talks, discussions. Excuse me. We can cover quite a bit. So I'm trying to see what makes sense. I want to talk about laser beam scanning, as you mentioned, Dominique, as a display technology that's we think has the great potential and from promise for having all-day wearable devices that's very non-intrusive and very fashion-forward. Which is certainly a key. I think one of your comments, one of the participants made a comment earlier about getting thrown out of a club because he's wearing Google Glass. Well, Google Glass is not a very fashion-forward type of a product. So, and we believe that laser beam scanning can certainly do that. But I want to sort of put things in context as well, because there's so much going on here. And lately, where we heard this whole Metaverse beast that's been unleashed upon us, I would say. And all the worlds of Twitter, pardon the pun, about Metaverse. So I want to just sort of give you sort of some thoughts on Metaverse, what it means, and how this fits into everything else, and how everything else fits into really AR, the display, and how everything sort of follows and goes downstream. And again, I invite, I don't know, Dominic, how you want to run this. I'm open to questions if people want to stop me and pause, and you can tell me, hey, if people have hands raised, I can stop somewhere and have a chat and make it more interactive. So I'm happy to do that, and hopefully, everyone will feel free to jump in as well. Okay, so here's what I want to cover. I'll talk about a quick introduction and set sort of the framework, if you will, for some stand. I talk about the Metaverse framework, and you'll hopefully see why that's important, why I raised that. Because that's been talked about quite a bit, but I want to really contextualize and sort of ground ourselves, which I think is the way to do it. I could be wrong, but I'll share with you what I think. And then from there, go right into AR glasses. Talk about what are the display challenges. Obviously, how does glasses work in the metaverse? Well, obviously, if I'm in the metaverse, I'm trying to coexist in a digital and physical world. You got to be able to see both worlds, and you want to be seeing both worlds simultaneously. And the only way we can see things simultaneously is through either a cell phone, which is not the most elegant way, or through a pair of glasses, some kind of wearable device that allows you to coexist in both meta world as well as a physical universe. And then talk about integration challenges and what it all means when you put all this stuff together, and then some closing thoughts. Okay. Okie dokie. So I love this quote for the metaverse. Let me pull it down. You can read it. I love it. Everything you never wanted to know about the future of talking about the future. And that is pretty much, and I didn't think about it. This guy at a wire talking about Eric, and that's pretty much what Metaverse is, right? It's a lot of talk. I'm like, okay, about what? Don't know, but that's what, it's just where we are today. Those of you, I guess you already know this basically. Metaverse comes from, the Greek, meta and verse, beyond universe, as we know, and then you can read the definition. And I won't go through the definition. You can read it for yourself. But the key things here, and it's underlined, this is Matthew Bell, a VC, a venture capitalist, who this quote's from. But a couple of things: it's massively scaled, obviously, because you're trying to parallel the physical domain in the digital domain. Obviously, it has to be interoperable because, like the real universe, everything has to work together. Everything is tied together in a very fundamental physical way. There are real-time, it has to be another keyword, and virtual worlds and you have to be synchronous and persistent. It's really, really important. So obviously synchronous, so you don't have any kind of issues in terms of interactivity, and persistency, so you can always be there. A rock, a tree doesn't move, it's persistent. In the same way, objects in the metaverse has to be persistent, for example. Got to have presence, because you're living in this world, like living in the real world. I sense somebody, I sense objects, I sense things. And so same thing there as well. And then there's a continuity of data, but that just really means that everything continues in real life. I see things in real life that continues to come to me. I walk, I drive, I see things. There's no discontinuities, and same thing here as well. That's a tall order. And how you do all that, I don't know. I'm not going to solve all that or discuss it today, but I want to talk about Metaverse because that's what's coming up here. I want to put together what that means in the context of devices and then what it means in terms of AR. This is another thing you've seen already before. Obviously, since our good friends in Facebook decided to rebrand themselves into Meta, guess what? Look at the search on us in Metaverse, right? It just went crazy. I was at the for those of you who are in the technical domain, I was at the SPIE conference back in January in San Francisco, where I'm based. That's Society for Photographic Image Engineers. That's the optical conference that everyone goes to every year, and everything's about Meta, Metaverse, not Meta the company, Meta company as well. And then, of course, for those of you who are familiar with this, here we are. Back in once again, we're at the hype. We're at the top of the hype. We're feeling good. Everything looks great. So-called peak of inflated expectations, right? Fantastic. When, like everything else, it's going to come down, and we will go out of the trough of disillusionment. That'll take some time. So we're all on a great high right now, but everything's going to wear off, and then we have to do the real work. And what I want to talk about today is what is the real work required in terms of what needs to happen, in this domain. And just to complicate matters even more, everybody's working. Now, this is a small snapshot of the various companies in the ecosystem that you can see over here. And this is what we know today. Every day is a new spinoff, a new company, a new announcement from a big company, a new acquisition. So it's just going to explode. And it is really what I'll call. I hate to quote. I don't like to quote Donald Rumsfeld, but it's what he calls unknown unknowns. Nobody knows what's going to happen over here. Okay, let's try to go into a little bit more detail. Again, guys, jump in and give me your comments if you'd like, and Dominique, I'll let you moderate that. So let me give you a framework of what I think it means. So this is something I put together a little while ago as I thought about it. And so if you think about it, no matter what the metaverse is, if you want to parallel the physical world and you want to parallel the digital world, the virtual world, you have to, at the top level, it's all about people, places, spaces, and objects, right? And spaces are just big areas, countries, continents, offices, theme parks, national parks. That's a place. Sorry, it's a space, excuse me. A place is a specific park, a specific office, a specific country or a state or a county, if you will, using a metaphor. So spaces are more generic, but descriptive, and places are more specific and very localized. People are people, obviously, or physical, or the avatars, but the people also non-human, if you will. You can imagine, animals and dogs and what have you, so on and so forth, and objects. It's like the universe full of objects, right? Whether it's clothing in a store or a certain mountain in a certain park or what have you, get the idea, right? So this whole framework is about connecting and having this coexistence of spaces, places, people, and objects to come together. And all these elements that come together, they have to have really 4 key attributes. They have to have persistence and presence. And persistence means that it's always there. If I go to put on a pair of headset and I'm looking at this metaverse and I go to a theme park, I go to a national park, a Zion, it's right there. The mountains there, the arches are there, the canyons here. It's always persistent. I know when I take it off, it's gone. When I put my glasses back on, it's there. That's persistence, the ability to live forever, if you will, or forever is can be, I suppose. There's presence. Who's there, what's there, objects and people. There's interactions, things interact in this space, of course, and there's perception, able to see. And perception is not just human perception. Objects perceive objects. If I'm doing a transaction, I'm buying something, there's a perception of saying there's a bank, there's a currency is being exchanged. They have to be aware of each other and sort of perceive each other in a broader sense. If you go a little deeper, to allow that to happen from a technology point of view, you've got to do sort of 4 key things. You've got to connect, everything has to be connected, got to sense, you've got to compute, because you got to figure everything out to be able to render it and know where everything is and do all the things you want to do in that domain. And actuate means move, physically able to move and feel. So those are the things that had to occur from a technological point of view. So that's really, so coming down from the highest level of abstraction, when all said and done, no matter what happens out here, don't care what happens. You got to be able to do these things. You got to be able to connect things. You got to be able to sense things. You got to be able to feel things, smell things, actuate, and you got to be able to compute, because in this fake world, this digital world, it's very, very compute heavy. So that's really at the highest level of abstraction, coming down into sort of a real world, anchoring it into technology.
I think Michael has a question. Yeah.
Sure, Michael, go for it.
Hey man, thank you. I love all this. It's very clear and very, codified, so it's easy to digest and, and make sense of it. The thing that's always bothered me about this, and Matthew Ball said this as well, talks about persistence as well, is the persistence aspect. So I totally get it where persistence is attaching some digital stuff to the real world, because as much as the real world exists, then the digital stuff, augments the real stuff. But a lot of the metaverse champions are game companies like Unreal and Blizzard and all these. So, and their worlds, if you will, are virtual, and they don't have an attachment to the real world. And they feel like they're a part of the metaverse. And
sure,
and so, for example, when you're in a game, you can look totally different from one time you play it to the next. Your appearance is not persistent at all, right? You can be a dwarf one day and a giant tiger the next, or whatever. So I just have some of the benefits of the concept of virtual is the lack of persistence, the creativity that goes into changing things, and it goes anywhere from super scary to absurd, or whatever, all the different emotions that you can gather from a lack of consistency and a lack of persistence. So anyway, just want to throw that out there, that for me,
it's a fair point. It's a great point. I don't talk about VR because I always think of VR as a specific case, right? That's a really good comment, by the way, and I thank you for that. I think, VR is a subset of everything, right? Because, we cannot interact as human beings simultaneously in the physical and the real world through VR, because you have an occluded view, obviously. Maybe you can do pass-through video, but then that's a whole different discussion. And that's not, I don't see us walking around with VR headsets around the streets anytime soon. So VR is what I call, is a subset of all this stuff, right? But if you want to truly live in the Minority Report of the world, or the Iron Man of the world, if you will, right? That's a different discussion. That's a superset. So yes, you're absolutely correct. You don't have to have these things, and the requirements are much easier to some extent, right? In the VR world, this is much more complicated. So I would say that yes, this certainly envisions VR, but as a subset. Okay, that makes sense. But thank you. That's a really good comment. I appreciate that. Okay, so let's go a little deeper. So when you think of the metaverse, now I got to think about what are the modalities of enablement. When you enable it, what are the modalities you talked about earlier? And so this some of this, again, this is not a complete. This is what I think about. I'm not the expert, so this is my sort of musings, take it at face value. But this is what I think has to sort of happen when you enable. So obviously we talked about awareness and perception, but that's not just to see, but it's to sense and also to map the environment. There's obviously interaction, which is pretty straightforward, how to interact with things, both physically through my hands or through my voice, some kind of gesture, but also in the background in terms of shopping and commerce and everything else. We talked about persistence already. There's the experiences as well, and that's a whole different domain. And what will be the experience? What will be the platform? What's going to be the software? How you deliver applications? That's another whole area, industry in of itself. And finally, it's a gateway, maybe the on-ramp. How do we even get on there? Even if I have all the other stuff, awareness, perception, interaction, all this other stuff. You still got to get on there somewhere. So today, what do we have? We got a helmet mounted displays. You got PCs, tablets, phones, smartwatches, and in the future, more things are coming. We got this company called Modes of Vision out of California, which has apparently developing contact lenses with AR, for example. There's also haptics, there's biosensors. I mean, the mind reels in terms of what's available today, what can happen tomorrow. But the starting point is that how do I see into this space? How do I get into this space? And so to me, I say that the one key enabler to access it, the main enabler, others are really important. It's not to diminish it, is to be able to wear a device and coexist in both worlds through a pair of glasses. That is sort of the holy grail. And I think everybody wants to get there, and that is going to enable a lot of other things. It's not take away from, you can still use tablets and PCs and overlays and everything else, absolutely. But in terms of having a sort of a very, very, in a very intrinsic way of accessing and having very visceral emotion, visceral connection to this duality of spaces, it's going to have to be through augmented reality wearable devices, in my opinion. Okay, so that's segue into AR glasses. So what are the challenges for near-to-eye display? Okay, so here is sort of very interesting. Well, a good friend of mine, Nikhil Balaram, who was at Google and later on Ivy Vision, I'll give him credit for this diagram here in the center. When we think about AR, there's really two kind of modalities today. There's what I'll call the practical and the useful, and the immersive and the niche. And that hopefully this is pretty self-evident here. On the useful side, you're talking about a pair of smart glasses where we're characterized by having it something you wear all day long, something you work inside and outside. It's very small, lightweight, low power, unobtrusive, fashion forward. You're not going to get thrown out of a club for wearing this thing. Then, of course, there's the immersive and the niche. That's the HoloLens, for example. The right-hand side is it's a glasses by a company called North, acquired by Google. In the right-hand side, to my screen anyway, is the Microsoft HoloLens. Great technology, great device, but what does it have? It has great resolution, close to the eye, not exactly close to the eye, very large field of view, and then has continuing varying focus. So you don't get this, you don't get any kind of motion issues in terms of depth perception, so-called accommodation divergence conflict. So therein lies a dichotomy. One side is like, yeah, I got this, outside I got this. And there's actually a pretty big gulf between AR glasses and helmet displays. And I'll tell you, it is not just the hardware. That is certainly a big part of it. Trying to cram in all that stuff is really, really hard to do in a small device. But also, and I continue saying this till I turn blue, is that there has to be today, haven't seen yet, a very compelling and very intuitive UI, user interface, and user experience. And more importantly, or simultaneously, what's a broadly useful application? I mean broadly, I mean your mother, your grandmother, your dad, right? The people who aren't technology people. What does that look like? So if you go a little bit deeper into the hardware space, let me try to cover this box I can see over here. Sorry. When you go a little bit deeper into this hardware space, give me 1 second. I'm sorry. I just have I see all the views here. All of you all. Sorry, get you out of the way. Thank you. You've got basically on one axis, you've got device sizes from HMDs all the way down to eyeglass type, and maybe contact lenses beyond on the x-axis. And on the y-axis, you go from sort of informatic kind of application to completely immersive. So it's a really nice way of thinking about it. Again, Nikhil did a nice job on visualizing this. So I didn't put the company names here just to protect the innocent, but you can imagine who they are. There's actually real companies today with products in this space. And so clearly the challenge here is that how do I get to the upper right corner, what I call the AR holy grail? That means that I've got a small form factor of eyeglasses and I get fully immersive and fully interactive. That means a very wide field of view. It means very high resolution. It means full interactivity, whatever that means. How do we get there? So today, glasses are down to the left. They're just informatic displays, which is, I think, is important, by the way. I'm not saying just, but that's where we are today. I put some symbology, text, some overlay, graphics, nothing more than that. if you go towards the origin here, go towards sunglasses, safety, and HMDs, you then start to get more interesting applications. You go to a media viewer, I can see more than just text. I can see a movie, I can see a clip, I can see pictures, everything else. And then finally you go to like the Microsoft HoloLens type, where you can actually do world locking and do some overlay, but it's still not full immersion and full interactivity. Microsoft's done a great job in HoloLens. Magic Leap, they announced something soon. We'll see what it looks like. But if you actually use a device, as good as it is, it's not a very intuitive interactivity with that device. That's the problem, right? It's not natural. It's good if you learn it. And so there's nobody there on the HMD side, and we're all trying to drive towards the Holy Grail, which is small form factor with full immersion. So that's the Holy Grail. That's what we want to get towards, and all that starts with the wearable device itself. That's got to start there. And so today, the challenge then is, how do I go from this wonderful device like the HoloLens, or the experience you get, excuse me, from a device like the HoloLens, and you cram all that into a pair of glasses? That is just really, really, really hard. I'll talk a little bit later about some of that technology, why it's really hard. And so to first order, the key things to determine how you get there are two things you have to have. Okay, you got to have a very small display technology. I'll call it a near to eye, obviously, and very compact display technology. And you have to have very efficient ways to take that light. It's called combiner optics. So what combiner optics means, basically, light's coming out this way, out from your face to the world. You got to take that and bend it around and combine it, and then bring it back to your eye this way. So you got to do a 180 on that, if you will. So you have to have the optics technology that combines that beams of light and then guides it back into your eye in a very efficient way. So that's what's really, really to first. If you don't have that, you can just stop right now and then go home, right? That's really important. The second thing I will say is that people want to do everything now. I want it now, and we all want things now, but we're not there yet. There's a lot. I'll talk about a little bit more detail later. But I would say that the market is not ready, and pursuant to our conversation we had before the recording started, in terms of applications that I mentioned, there are broad and useful applications today. I'll call it smart glasses, meaning that you have overlays, the information display, you have work instructions, workflows, you have directions. Maybe you're fixing a tool, an arrow points saying, change that bolt out, or replace that PCB or circuit board, or whatever you're doing, or even oil rig, do this with the drill, or what have you. So you can imagine a number, or if you're a doctor, you have patient's record coming up on your, or a nurse, the record's coming up, for example, the BP or some other kind of stat. So you can imagine a lot of applications that'll be very useful for what I call smart glasses, which this form factor can be achieved, and that application can be achieved. Then, as technology is mature, as a function get more mature, as the market becomes more mature as well, by the way, then we can add more and more and more functionality. That way, you kind of like build this up as you learn and you learn, and you get a progressively more sophisticated devices that can actually meet what's needed by the market, not what the marketing guy is asking you to do. Okay, that's two different things. So think about the market, not the marketing guy. I'm also a marketing guy as well, also being technologist. So I will take that criticism. Excuse me. Okay, so let's go a little bit detail. So laser beam scanning, what is it, and why is it important, and how does it work? So I got to move this viewer thing around here. Good. So it all starts with what's called a MEMS device. MEMS stands for micro electromechanical system, which is a very, very fancy way of saying it's a really tiny, tiny moving part that is fabricated on silicon technology. And so in this picture over here, excuse me, I've shown you on the left-hand side, to my left, hopes you're left by the US, by the penny over there, what's called the MEMS die. This is the actual die that comes from the wafer. It's a very, very tiny, tiny mirrors. These are basically two tiny mirrors that can move in one axis each. One moves in the x-axis, one moves in the y-axis, and together you can move the x-y axis. And so you can see how small the device is. You can see the package for the MEMS over there, and relative to a penny, tiny, tiny. It's even smaller today. This is an older picture, or older image. How does it work? You've got basically a mirrors, or one or two mirrors, you've got a bunch of lasers, red, green, and blue. Obviously, as you know very well, R plus G plus B together can give you the full color palette. We can argue about colorimetry and color science people, but for all of us, for all those non-color science people, R plus G plus B gives you the full spectrum that you need for most displays. And so the lights come out of laser diode, they go to what's called collimating lenses because the lasers coming out diverge rapidly like this. You got to bring them back in and collimate them. So you collimate the light and then you combine them together into one beam. That one single beam of collected R, G, and B hits a mirror. The mirror scans back and forth in 2 axes and it does a raster scan pattern. For those of you old enough, it's like a CRT screen, basically just raster scans back and forth, really, really fast. And so your eyes will then see the image on a projector, like a movie theater, if you're using a projector, or through these optics into your eye. What we do is we take that, we put it in a very small, very small device. So next to that, that RGB, the little laser pictures over there, see a small module. That small module is about 1.5 cubic centimeters, tiny module that has all those elements. That's stuck onto a pair of glasses. That's an actual photograph of a glasses that we put together with our partners, and it goes in a little module. The module goes in the temple of the glasses, and then couples to the waveguide. So on the upper side, you see this eyeglass. This is a single monocular glass on top. That's what's called the diffractive waveguide. And putting it all together allows you to see really nice AR images. Let me go here. I'll come back to this next. Where'd it go? Okay, you go. I'll go. So this is what it looks like. So if you go to the glasses themselves, this is what you see. This I've shown this to customers and trade shows when you can go face to face. But basically, this I mean, you have symbology, text, and overlay. So this is a silly example of right, little pick up your laundry or some breaking news or whatever it happens to be. But you get the idea. You get an overlay into a visual field of view that allows you to have some informatics that's helpful to you. This is an actual photograph taken through a cell phone camera. So the colors aren't quite right because you have a cell phone camera RGB sensor, and then you have that then going to the laser and going to a waveguide. But it looks quite good. And this is what I mean by symbology, where you have useful data for everyday application. I'm going to go back now to here. So we've taken this stuff. So what have we done? So as a company, ST, this is what we do. We're a hardware company. So we go ahead and in the bottom, you can see how complicated. I show you this stuff not to wow you, but to say how complicated it is. 1.5 cubic centimeter volume on the bottom left-hand side of the screen. You have something called a Vegaless module. Ajam is a partner of ours, so I'll give him good credit for it. We cram in the lasers, the combiners, the accommodating lenses I showed you earlier, all the optics into a really, really tiny area. And on top, there's a bunch of different chips you see up there, or various things you have to have. I won't bore you with it. You have to have drivers and laser drivers and processors and so on. They all go into a PCB. And all of that looks like the center diagram. It's just a rendition of what it looks like. And that's what we put together into this pair of glasses. This glass over here, I said earlier, here, you see the rotation. This natural glass that we designed. This is not a product. This is just to say, hey, we can do it. Here's how you do it. And here's how you get there. And so this is a very, very small, reasonably small form factor glasses. It weighs about 58 grams, which is less than the 80 grams required by the eyeglass industry. And I saw already before I already showed you earlier, just the last slide, the images as you see through those glasses. It's got a 30-degree field of view. I know earlier one of you said to me, hey, that's not enough. I need more than 30 degrees. Well, I will challenge that notion saying that for these applications, for symbology, you don't need a lot. You're not doing immersive stuff. It has very high brightness. We call this candelas per square meter, how you measure it. 1300 is very good. What it means is that you can also be in reasonably bright conditions as well as indoor so that you can work in many different environments. If you're not bright enough, then you have to go to a very dark sunglasses type. We've got to work indoors. That's why it's important to have brightness. And again, this other data I won't bore you with, but you can see some of the characteristics of this device here. Okay, let's go next one here. And so the key things here are we want to get to what we call heads up, hands-free, all-day wearables. It's really, really important. So you can sit around and just do stuff when you want to do it. And by the way, we believe it's for episodic use. You're not going to have something all the time in front of your eyes as you're walking around. That just doesn't make any sense. I mean, you need something. You may walk around the street. You may want to, if you're in Japan, you see a sign, you can't understand it, it'll translate for you, maybe give you directions. Maybe you have a message coming up. It's episodic, so it's not constantly being used. But it's got to be lightweight, so you can wear all day long. So it doesn't give you a headache or put a depression on the bridge of your nose. It has to be very fashionable, so you can get thrown out of clubs, for example. It has to be very low power, so it doesn't get very hot. Or you have to have large batteries, and so on and so forth. And so we think about two things. We think about field of view, and I want to really impress upon you here my view that for smart glasses, where you're just trying to have information, having something way out here, you're not going to be able to see. It's your peripheral vision. You have much lower resolution, not going to be able to see it. So you don't want to make something too big for fixing something or work instruction. We found 30 to 40 degrees more than enough. In fact, probably just more than enough for that application. When you want to be immersive, you have to be much, much higher, greater than 80. Ideally, you want 180. So you can do, you can turn your head like this and look around and see everything world locked and seamless. So that's a difference. And same thing resolution. People always say, give me more, give me more, give me more. I'll say, well, why do you need more? Tell me what you want to do. If you're doing simple text and symbology and overlay and work instructions, you don't need more than what I call 720p. By the way, we shouldn't talk about 720p or 1080p. We should talk about pixels per degree here. But anyway, having said that, 720p is what we talk about today. That's enough for that. When you go immersive, when you have like realistic objects that's world locked and anchored in space, you got to be very high resolution, much greater than what's called 1400 or even 2000 and even higher than that. So those are important things to talk about. Eye box, I don't know how much you guys care about it, but eye box is very, very important. You have to have a large enough eye box so that anybody can wear the glasses without having to adjust your what's called the interpupillary distance. So that's some of the characteristics of the display. So I'll show you how this works. Here's a quick little video. Here's how it works. So lasers come out through the beams collimating, combine, hits those mirrors. The mirrors go back and forth, scan back and forth, and the image comes out projected, and that projection goes into a wall, or because a virtual image that gets sent to your eye through the optics. That's how laser beam scanning works. This showed you earlier already. This is what it looks like. This is again a 30-degree field of view. It's quite enough, I believe, for this kind of applications. Okay, and so this again a little more techy. I know one of you guys are engineers. Was it Eric? I can't remember his name earlier. I don't see him here. You know, I know you know a lot of engineering degrees. I think Michael maybe he may be technical as well.
Yeah,
I don't want to spend too much time here. Yeah.
Jim is the
Thank you. So,
engineer.
I'm sorry.
Jim is the engineer.
Oh, Jim. I'm sorry, Jim. Sorry, I did see your name. Forgive me. Thank you, Jim. Forgive me for forgetting your name. So this is a so example what's called a radar diagram for those of you who are the military or defense, kind of things before. Some people call spiderweb diagram, but the idea is saying, look, things interact here. So when you design a system, you can't have it all. I know you want it all, but you can't have it all. You can't have the highest brightness, the smallest size, the lowest power, the biggest field of view, lightest weight, the highest resolution, right? It doesn't work that way. Life is not like that. You got to make trade-offs. The really cool thing about laser beam scanning, of course, all the technologies, is that it scales very easily. You can make these trade-offs within the same architecture. You can't say, look, you know what? I'm willing to give some power, but then I want higher brightness. But I want to be small and lightweight, but I'll give resolutions. It can be small, lightweight. So you can do these trade-offs really nicely within an envelope, and it gives you flexibility, and it really allows you to do a holistic design. So one of the things I keep telling people is that please don't come and tell me I want the fastest, best thing. Don't tell me what you're trying to do. Tell me what your problem you're trying to solve. Let's figure out, when I build my system, where I want to give, where I want to take, right? Because if you don't do that, and you say everything has to be the best, everything has to be the most tightest spec possible, you will never build anything. It'll be too expensive or it'll be impossible. So you have to really think about the systems view. This is where I think, I just speak my own personal belief, not my company's belief. This is where we sort of failed in sort of US engineering and US education, is that we don't think about systems anymore. If you think a lot of the work done by NASA and the DoD and others as well, or even large companies back in the day, they thought of the system first. And then they came down and said, okay, well, this guy is not that critical. This guy's not critical. Let's make sure we apportion the complexity so that we actually have something that works. And that's what's really missing now. So my point is always think of the holistic design. What am I trying to do? How am I going to use this stuff? Starting with that, work backwards, and then design a system. So what's good at laser scanning is that once you do that, as an example, once I go to a smaller field of view, then I can do a trade-off. So you know what? I can trade off. I can do a monocular. I can do a high brightness, but I don't need to have, I need to have high resolution. Or if I want to be fully immersive or want a much other field of view, I can handle a lower brightness because it's mostly indoors anyway. That means I can have, lower power, for example, right? There's a lot of things you can do, and that's the whole point. That's why laser scanning is really ideal. That's the way that's probably a technology of choice for near to eye displays. And so that's what I want to say is, the holistic is true, not just for this display portion, but the entire system. Not the entire system, but the product and the application. So you have to come together, all of us, from the UI, UX designers to the application people to the hardware, because if you don't do that, you'll sub-optimize and you'll have some pain somewhere along the way. And you will not apportion pain accordingly through the entire cycle of development. Sorry, Michael, you got a question?
Hey, yeah, thank you so much. So I don't know if this is appropriate, but I wonder if it would make sense to talk about a use case on this slide as the way.
Of course you can. Sure, absolutely. Go for it.
Okay, so our company has two different use cases that we've been pitching, and basically what they do is they provide camera feeds from a live event to the audience. And let's take two different use cases. One would be I'm sitting in a concert hall, and there's a pianist who's giving a recital, and I want to be able to see their hands from within my seat, so that I can just watch something that I can't see from my seat. And then let's go to a sports stadium, and there's a football game on, and I want to be able to see one of the cameras that's on the ground level focusing in on the quarterback or something like that, something that I can't see from my seat. Right now we do it with a phone, which is really awkward in the concert hall, and it's not so bad in the stadium's experience, but it would be much more enjoyable, I think, if it was wearing glasses instead. So anyway, just throw those out to you, and if that's useful, that's great. If not, then don't worry about it.
No. It's useful. Everything's useful. Like everything, like I say, no one knows everything, and no one knows anything. In fact, it's good to really collectively come together to understand what these cases are. So I do appreciate that. And what I was going to say is that all this can be done. As I said, it's a question of what's the price and penalty you want to pay. I think the case of real-time video feed to your wearable device, call it whatever it's going to be, there's really two challenges here. One challenge is the bandwidth itself, right? If I'm transmitting, real-time video in a stadium, is a bandwidth. Now the good news is 5G is there today, and a lot of the stadiums are also 5G connected for this very reason, I think, right?
Yeah.
Maybe concert halls will too.
Yeah, and we have a solution for the stadium broadcast technology.
Perfect. Exactly. So anyway. Perfect. There's that. The second then becomes the real-time rendering of that, onto your glasses, right? And how does it get rendered? Is it going to get rendered up here with some kind of a host processor, or is it going to get rendered sort of tethered, right? And so that becomes complicated, because if it's if you're doing a real-time rendering of high high bandwidth video, it's a lot of power and there's latency and stuff. So you want to minimize all those things. You don't want to have the quarterback move and then you're here and now, right? Kind of lag by right? That would be awkward. So we want to have real-time rendering and very low latency. And so trying to cram out, it can be done. I'm curious to know what Magic Leap has done. Obviously, HoloLens is too big. You don't want to have a HoloLens stadium, right? Obviously, you're gonna look like a total dweeb, and you probably get kicked out of stadium as well for wearing that.
Well, I think eventually, the ideal would be that they can hand the glasses out as you go to your seat, or something like that.
Love
or
that idea.
you know,
Yeah.
rather
Yeah.
than you have to wear your own.
Yeah. So I would do that in several steps. The first step I would do it is I would do it in tethered step. You can have some kind of a, it won't be glasses. It will not be this. I'll assure you, you're not going to get this form factor, right? Even for that, it may be a little bigger, but bigger is, bigger meaning, it won't be like, it's not going to be Oakley's, right? But it's not going to be, it's not going to be HoloLens either. Something in between, and that's okay in a stadium because no one's buying it, right? If you're all wearing it, it's okay. I would say you could do that today. There's a power penalty, but if everybody has either the wearable device with a small little compute in the back of it, for example, right, or tethered to something that they can have in their waist, two ways of doing it, right? That you want to do, because if you don't, then it's going to cause a lot of the problem. You're going to try to jam it in. So it can be done today for sure. I would absolutely love to. That's a great thing to pilot somewhere, Maybe make it available only to all the guys in the box seats or the ones who can afford it, right? Eventually go up the stadium to the nosebleed seats. I don't know, right? For example, but that's a cool idea. It can be done. The question is, it's a trade-off. The answer is yes. The thing is, you need to find a partner because you can't just go buy something off the shelf, right? But if you would, are you in LA? Where are you based?
Yeah, we have good seats at SoFi, and
I was just gonna say, SoFi Stadium, man, perfect. Congratulations for the Rams, hell of a game. But anyway, yeah. So SoFi Stadium, great, state of the art, brand new, right? What better play? You have Hollywood there, you got money there. If you're really serious, you want to pilot this stuff, it can be done, right? It's gonna cost some money in terms of getting the right partner and some NRE to build this stuff and prove it out. The technology is there. You just got to figure out the trade-offs, right? How big do you want to be, right? Where do you want to, there's some design challenges, which I think is really easily overcome. Not easily, but it's engineering problem, not an R&D problem, to put it that way, right? It can be engineered in. It's a cool idea. This is what I love to hear. This kind of niche initial experience for customers, to people to feel, not to buy something, just to experience something and go. Episodic cases, right? That's the way to do things. So yes, I love it. Yeah, Jim, go for it.
I'm just thinking in that use case, if you've got a stadium or something like that, or an auditorium, perhaps you can bathe the stadium or auditorium in the signals that you need, so that you don't have to have tethering to a device in someone's pocket or something like that.
Absolutely can. I mean, so if no signal, so certainly from a wireless connectivity point of view, we could certainly have that, right? I bet SoFi has 5G all set up in that stadium, right? For sure, I would think. So yeah, you're absolutely right. So I think everybody can get the same feed simultaneously, and it's a question of the receiving side of the 5G signal and the rendering. So I want to talk about tethering in terms of form factor. I would say that, in fact, I can't tell you the company's name, but I just worked with the company. Now this is back to my company. We lost something to the company. There's a partner of ours. We're going to do a demo for CES 2023, I hope. They got a pair of glasses. It's a little larger, but still pretty fashionable. And they've got a little pack that's untethered behind it in the back of the head on a strap, so that you can counterweight the balance, right? So you have a nice balanced headwear there. And in the back's the compute pack. So that it's not tethered, but it's a compute pack, because the difficulty is that when you have a very small form factor and you have a high performance GPU, you generate a lot of heat. You need a lot of power, so you want to make sure you can have a large enough volume to do the thermal management, for example, and space to to hold it. So you're absolutely right, Jim. That can be done today from the wireless connectivity point of view, but you still have to do computation for the rendering on a local point of view, because you have to render from here to the display driver for the glass itself, right? So in other words, the video feed comes in, and you got to do scaling or deinterlacing or some image processing to re-render it back into the aspect ratio or whatever else it is for the glasses, right? The colors and the color space and so on and so forth. So that has to happen locally. Now, can you do that remotely in the cloud? I don't know anything about it. Maybe you can, Jim. Maybe you can do that in the cloud and send the. You know what? Take it back. If you're brainstorming now, take it back, because you're all wearing the same devices, right? In the same architecture. You can, in fact, a priori, re-render everything. And so here's a trick. I got to get the live feed and the broadcast feed, and I got to really quickly and I'll probably have some servers there to do all the rendering really fast, really low latency, and send it over and you can have a dummy display on the head. That's an interesting idea. That possibly could be done. That is an interesting idea. That requires the ability to work with the stadium, work with the technology. But if you already have all that, and you've got a closed, controlled use case environment, and you've got the stadium owners and the technology companies and whoever else it is all bought in, because it's so well controlled, you got to do that. That's not a bad. That's a damn good idea. So, sorry, I'm brainstorming now as you're talking about it.
Yeah,
it can be done.
Just to elaborate, so we do have a server there at the stadium, and it's taking all the feeds from all the cameras. It doesn't interfere with the existing broadcast at all. It just duplicates all the feeds so that we can do our magic with that. And then once we have that, we print everything onto we have a patent on this, just so you know. We print everything onto a single feed, and then the people in the stands can choose whichever part of the feed they want to see. So they're actually receiving all the camera feeds all the time, but they're focusing in on a field of interest, essentially. And that's what fills their field of vision. Or currently the display on our app. And in terms of the wireless technology, I used to be one of the chairs of the IEEE 802 wireless committee, and so I'm really familiar with 3GPP and Wi-Fi and all of that. So what we're doing is we're going to use true broadcast in the stadium to broadcast that video feed, and that way we don't have to go through 5G. We don't have to go up to the cloud or up to a cell tower or over to an AWS wavelength and then come back. So that way we get really fast turnaround in terms of latency. It's on the order of 100 to 200 milliseconds, something like that. So it's really not bad in terms of latency.
Yeah, and before I go to Emily's question, just to finish that thought here. Yeah, so to back to Jim's point, I just thought as I brainstormed live with you guys here, just literally making stuff as you go along, if you will. So since you have servers there, what I would then do is that to avoid tethering, to really minimize latency, I would do not just to take the live broadcast feeds, and then through a separate pipe, take them and render them, because they're assuming, since you're handing out glasses or whatever headsets to people, they're all having the same one. So now they're going to behave. So you can do all of the pre-rendering, or the rendering, if you will, that's required for the glasses to reduce the burden of the compute on the headset. And that way, maybe you get a small form factor. So that can be all done on the cloud basis. You got fast communication over there. You can turn around. If you have a server, you can do much faster rendering than you can on a GPU on a headset. So this could be interesting, man. It could be really, really interesting. So
sounds like there's a patent. Sounds like there's a patent in that.
It could be. Yeah. It's the danger of brainstorming live, right?
Yeah.
But yes. Yeah.
Cool, man. So, thank you for that. I appreciate your taking my use case.
No, thank you, and thanks, Jim. Emily, you got a question, so I don't want to forget to see your hand up there. So.
Hey, I'm loving this. I think we should write a business plan, right after we get off here.
Yeah.
I do work in healthcare, and I grew up with Intel and Siemens doing IoT. One of the showstoppers is the juice, the battery. As much as I would love to do all this interactive stuff in a stadium or in an operating room, or firefighters with drones out on the front lines, to me, the battery, the juice, is the killer, the obstacle. So I'm wondering if in this model that you're presenting, are there considerations for that? We have, like in the OR, we're testing some IoT devices, but you have to keep swapping, even like during a 5-hour surgery, you have to keep swapping the battery, and it's kind of a pain, and it could be dangerous. So I just wonder if that falls into your model in any way, or if you could, later on send some pointers on how to address some of those issues for healthcare or frontline workers, augmented work.
So there are 3 main areas of power source, of power drain, so power consumption. What the biggest one is display, and that's why laser beam scanning is ideal because it's very low power. So right now, just give you an idea. For at least for some symbologic type of applications, you're talking about power consumption, you know, on a normal use case around 300 milliwatts, okay, which is quite low. Which means that you can basically, and we are assuming a 25% duty cycle, meaning that the content, you know, roughly quarter of the day is, 8-hour day is where you're having content, because people don't watch a movie all the time, right? For example, that's one aspect we look at very carefully, and laser beam scanning is probably the only solution today that allows you low power, because the way it works is that other technologies for displays, it's always on, you know, except for micro LED. That's a future. That's many years away. So today you've got something called LCOS, something called DLP, for example. OLED doesn't really work that well. So those two are there, and they're constantly on all the time, and they consume a lot of power. The way laser beam scanning works, I showed you earlier, is that you have, you know, the laser light, the amount of intensity at a certain pixel is basically, you know, delivered to that pixel. So if pixel is dark, for example, right, there's no content there, laser's turned off. If the pixel's, you know, half bright, you have half the amount of power for the brightness, so on and so forth. So when you have content that's not textual based and everything else, or informatic based, most of the field is pretty sparse in terms of bright content. Even within the content itself, we have dynamic modulation. So therefore you have much lower power consumption, you know, by definition for laser beam scanning. So we do address that. So that's one area. The second area where we have a lot of power resources equally is the compute size. I mentioned earlier to Jim's comment about, hey, can we do something in the stadium level? Meaning that if you have to do all the rendering and all the graphics and all that kind of stuff here on the headset, I'm going to have a computer and a GPU. So you said you work Intel, right? So you have to do a lot of computation, and GPUs can be power hungry and also get hot. And the third one is, of course, connectivity and bandwidth, right? The higher the bandwidth, you know, the higher the data rate, the more the power you consume. So all that can be addressed for sure. Certainly, this technology, the reason why we really push laser beam scanning is because the power is really favorable. And as a company, without giving too much detail and boring you guys, we have a roadmap that goes into lower and lower power over the next coming years. So to answer your question, back Emily, yes, it can actually be done. We are looking at it. So from this talk, it's certainly true here from the display point of view, and we now have to really look at other parts of the system as well to do that. Okay, hopefully answered your question. Before I take Jim's question, does that give you some insights there, Emily?
Yes, thank you. That's very helpful. I appreciate it. I'm glad you're addressing it because, you know, I remember the days when we had like 60 pairs of Google glasses and the doctors would throw them across the room because none of them would hold a charge. So
yeah, that's bad. Now, our goal is to have at least for smart glasses. Now, OR, different. I got to think about that. Now, what's required over there, but certainly for smart glasses, you know, we think of using a 400 milliamp hour battery, which will give you enough juice for, you know, 8 hours at a 25% duty cycle. Means you only using a quarter of the time, right? Kind of a thing. Okay, just to give you an idea. Great, Jim.
Well, here's an idea. Here's an idea regarding power. I know when I've searched for headphones and so forth in the past, something that has shown up, and I think probably Sony, Panasonic, and other companies sell this as well, is a pair of headphones that they're pretty small, where they go into the ear, but then they have a piece of plastic that comes forward, and it's like a loop of plastic that rests on the chest in front of the wearer. And what I'm thinking is perhaps some battery power could be put into something like that, and then you could connect that to your system in one form or another to provide an extended battery supply.
No, that's a good idea from a product point of view. Absolutely. Ultimately, you want to have low power, period. You know, but we may have to do that. We have to do that in like steps, right? To a point. So absolutely. I mean, I think all those ideas are absolutely welcome. And so from OR point of view, you know, it's like you can have a backup pack to your cell phone, right? for example. You can envision something here that maybe not as obtrusive for those kind of mission critical applications like surgery, for example.
I usually wear gaiters or something like that.
Mhm.
When I'm wearing glasses. Those could certainly, feed power to your
Mhm.
glasses pretty easily,
Mhm.
and they're stylish. There's a bajillion different ways of wearing gaiters, and they could plug in instead of just hooking around the eye, the temples.
What do you mean by gaiters?
Just a cord that runs around your neck, or some people wear it in front, but it holds your glasses so that you can just let them fall onto your
Oh, okay.
chest when you're not wanting to look through them. And
That's true. That's true.
and also
I'm wearing them right now.
and also if you're running or and they happen to fall off, then you won't lose them, so that you can just easily put them back on again.
Yeah.
Great. Some more ideas for you, Emily. From these guys, it sounds pretty good. Okay, so let me continue going and let's see. Let's see. Oop, okay. Integration challenges. Here we go. Now, if you want to actually have a fully functioning pair of glasses that allows you to do all the things I mentioned earlier, you want to have sound, you want to have really good quality sound, obviously coming through it, but you don't want to be, maybe you don't want to cover your ears, right, and have occluded sound, for examable. You want to have unoccluded sound, but also privacy at the same time. You may want to have, some kind of voice activation assistant, potentially like Alexa or OK Google kind of a thing for certain things. For example, you certainly want to know, is your head tilting or not? Am I looking left? Am I looking right? Am I looking up? Am I looking down? So we know which. You can do both head tracking and gaze tracking. So you need to have motion sensors for it. You need to have ambient light sensor to correct for the brightness. You need to have combining optics. You need to have time of flight sensor if you want to do some level of localized mapping. So I put a whole bunch of devices here saying this thing gets pretty complicated. So display is one portion of it, but you gotta have a whole bunch of other things up there, right? And they all have to integrate together and work together at the same time. And it's quite a bit. And on top of that, when you want to really go ahead and map the environment and have fully realized pair of immersive glasses, you have what's called SLAM, which stands for simultaneous localization and mapping solutions. You can map your environment as you're walking through it. You need to have wireless communication. You have to have wide data bandwidth. And I cannot stress it enough. No one's at any work in this area, no matter what hype you hear. I have yet to see an intuitive user interface, user experience for this stuff, right? I've yet to see that. I don't know what that looks like. I just don't know. People are taking what they do with this guy here and mapping it here, which is not the way to do it. You got to sort of think differently now, for example. And so trying to do all that, the tiny glasses with low power, low latency, all the applications, it's a challenge, right? We're not there yet. So I love the discussion today because, I didn't even think about these things, right? The stadium application. Now, certainly I was aware of the use of the HoloLens, for example, in the OR, but not as much. But getting the feedback from you, Emily, about what's required in terms of the power and everything else, and then Michael and you and Jim in terms of the other ways of doing it and other applications, I think is great. So this is before I talked to you, I said, hey, this is what we're trying to do. We're not there yet. We got to get there and try to get in a pair of glasses. It's coming, but not not tomorrow, but maybe with next year or two. We can do all that in a very cohesive way. But that's what's required. That's what we're working on right now. So that's really the complexity to integrate all that. And that's just one part of it. That's just hardware portion. I said before, there's a whole back end portion. So the UI, the interactivity, and the applications as well, you got to think about. So it's a non-trivial task to be sure. And again, I just put over here, from a system point of view, we got to have all this stuff come together. This is an eye chart, but you got to have all these things come together seamlessly. And that is what's really, that's hard because no one company does all these things, right? All the big companies claim to do everything, but no one can do everything. That's the whole point. And then just like the natural world, you have to have an ecosystem. Obviously we're not doing a good job as humans, but hopefully we'll do a better job. But you have to have a good ecosystem to have a thriving life forms, if you will. And the same thing here in the world of developing products and technologies. You have to have an ecosystem that allows the entire environment to thrive and to be self-sustaining, for example. So you have to have this, at a very minimum, all these areas have to come together and as an ecosystem and come together seamlessly. So I don't want to waste time on this chart. What I want to say is that one of the things we put together is what I call the LaSAR Alliance. It's just in terms of at least a display portion. We created an ecosystem of companies and of coming together to address all the challenges over here. So we had 6 founding members. We have over 20 companies now. We're all actively working together to address power, field of view, to address weight, to address colorimetry, measurement of what, how do you measure these things? What kind of optics is required? How do you get small optics? What kind of films are needed? I mean, a lot of companies, there's materials, there is optics, there is photonics, there is electronics, there's a whole bunch of stuff comes together. So we want to just solve this tiny part of the puzzle. It's just that portion we're trying to solve. We have an alliance to do that. And that's just only the display portion. So imagine now what's required for the entire ecosystem in terms of trying to support the metaverse in the future. Imagine just even doing what you want to do, Michael, in a stadium. What kind of ecosystem is required? As I mentioned earlier, at least you're controlled. You have a closed ecosystem. So you've got the stadium, you've got the content, it's a football game, right? You've got the server, that's great. So there's the ecosystem, but you got to have who's the headset partner going to be, how to integrate it, who's going to be a 5G partner, for example, who's going to deliver the content, do the overlay on top of the live feed that you're going to get, and so on and so forth, right? So one can imagine, right? You got to think of alliances and partnerships. So my point here, you're not so much focused on being scanning, but just say you've got to think of things holistically, but also in terms of ecosystems as well. And what we don't do, unfortunately, and what I've learned in my sort of a long career so far is that you've got to have ecosystems, you got to have partners, you got to think outside of what you need. So I always think about, well, then what? And how do you use it? And who's going to use it? And how they're going to use it? I mean, that's something I'm struggling with, because I don't think anyone's answered that question. Again, I think within you, Emily, and certainly Michael, you've already thought about ideas, right? In terms of use cases. I love that. So you got to think more what's required over there, basically. So that's, I think, where it's at. Some closing thoughts, and then we'll talk some more. Some closing thoughts. So I want to go back to Metaverse again and bring it all together, right? What is the Metaverse? Honestly, I don't care. I really don't care. What it's going to be, how it's going to be, it's irrelevant to me, because guess what? It doesn't matter, and I don't get caught up in the hype, because no matter what happens, the things I said earlier have to come together. You got to sense, you got to interact, you got to display, you've got to do some connectivity, and so on and so on and so forth, right? There are a lot of pieces of the puzzle today, for sure. But then there's something that addresses things broadly. The only companies that's done anything is Microsoft HoloLens, but that's a very big form factor. Maybe Magic Leap has something. We've done some stuff together with a partner on the glasses, which is not sophisticated, but we're coming together. But the display is a first key step. You got to have that, and that's what we are really driving to make sure that we can enable everything else through laser beam scanning. But again, I say the key question you got to answer though, and then right now is, how will people use this stuff? Wow, and what will they do with this stuff? Right? And how do you drive? I am misspelling here. How do you drive broad market adoption? That's really, really what we all have to think about. Is so what? That's a so what is a really important question and a really hard question. And really, really, final closing thoughts. I love Yogi Berra. For those of you who know him, right? Got a great quote, and the quote is, "The future ain't what it used to be." You got to really think about that for a second, right? And I love that quote, right? And so really, I would say that just like the internet, no one had any clue we'd be here today in the world of Twitter and Instagram and TikTok and all the, no clue. You could never envision this stuff, right? And no one knew how to involve, and that'll be itself the metaverse, right? I have no idea, But what I do know is that certainly the building blocks to get there are pretty straightforward. That won't change. And maybe we can then think about little applications or very focused applications. Again, I love what you guys talked about there on the phone, is to start with, on this call today, sorry, and to start thinking about that to sort of maybe point the way to the future. So anyway, that's really what I wanted to sort of close off with, sort of, kind of come full circle in terms of starting the metaverse, closing of the metaverse, because it's a big buzzword, and I want to maybe use the metaverse word, to get your attention, but really talk about all the other stuff we talked about. So Let me pause there, guys, for any questions or comments and additional thoughts, or anything you have.
Gene?
Hey, Jim, go for it.
Yeah, you showed a curve early on in your presentation of about adoption, basically. And Dom and I have often talked about this, where there have been many waves of, say, virtual reality. And, it comes, it goes, it comes, it goes. In the past, one of the big problems has been the hardware just was not there. And so it went. And then it comes back again when the hardware gets better. I think this time, perhaps, we have good enough hardware where it's going to stick. And but I think that part of that hardware solution is what you're doing. And so when you show that curve, you could have a curve without the AR glasses, like you're describing, and a curve with them. And I think the two curves are different. The other thing is, you talked about adoption, early adoption by the enterprise, and then moving more into mainstream. And I think that's probably an accurate description of what's going to happen. But there's another factor in here that I think of as the Steve Jobs factor. And that is, Steve Jobs would give people products before they realized they needed those products. And I think these AR glasses may fall into that category. Unfortunately, we don't have a Steve Jobs anymore.
Yes.
And I don't think Apple is as visionary as it used to be, although they're doing good stuff. But there's always the opportunity for something like that to happen.
No, that's a really good point. Like, I mean, Steve Jobs is unique, obviously, as you pointed out. And, this is what commonly known as, right now, what are the unarticulated market needs, right? Who can figure that out, right? I don't know what I want, right? Kind of a thing, right? But I know what you want. And who is that? Who does that? You're right. We don't have that. Absolutely. So in lieu of that, and what's always worked is that, at least, okay, let's use it for where you can use it. Use it where you could use it, and then that'll drive the way. That'll get familiarity. But again, I love the idea. I tell you, I love the idea in this call today of the stadium. That's really cool. I love football too. I love to have that, and of course, medicine is very clear. I would say, Emily, not just for the OR, but imagine a nurse, practitioner or nurse walking around and just just having going in the room and checking on a patient at night, they're sleeping, and then it comes up in the glasses, right? All the data that she needs or he needs.
I work with the Open Voice Network. My specialty is voice AI, okay, the company that I work with. But the Open Voice Network, we are actually writing guidelines for remote patient care or remote preventive care using voice and augmented reality. We do focus the doctors, there's not enough doctors and nurses, and we have, a whole slew of seniors. But my question to you, if I may ask, are you working? I do look at the clinical studies and the products that come out of Asia. Okay. They get it. They're way ahead of us on voice, so our company works with them in automotive and vending machines, appliances. Healthcare is harder because I have to, educate the world in the US. Even the regulatory people, they think voice is call centers, or chatbots. They don't get it. So I'm wondering, do you have any traction or working with partners in Asia who, because the government has set the bar, because the funding is there to look seriously at these real use case models, to kind of break through the obstacles, and they're very creative with batteries in Asia, so, things like that. So I'm just throwing that out there, is because healthcare is global, because mobility technology is moving so fast that maybe we could, explore that together and see what would come of that.
Yeah, I mean, like we're a large corporation. We have 46,000 people. We have operations in all the countries. Asia's, regrettably, again, I say, and I mean this, we don't do enough of this in the US anymore. US is all, writing code, right? Hardware is, it's, except for Apple, it's we don't do that unfortunately don't do a whole lot of that. So a lot of this stuff comes out of Asia. A lot of our partners are in Asia. So we work very closely with partners out of Taiwan, Japan, of course, China, as well as there, and Korea. So the answer is yes, we absolutely do work at different levels. We have manufacturing facilities, in Asia. We are a European company. We're headquartered in Geneva, but we are, we have partners in all the Asian countries, right? We have, Singapore. We have operations in Singapore, manufacturing operations in Singapore, Philippines, Taiwan, China. From a manufacturing point of view, we have just, sales, marketing, and technology people and all over the place. We do. So it's just, the short answer is yes, we do. The glasses that we're working right now with a partner in Asia called Quanta Computer. They're a $33 billion company. They do a lot of stuff for Facebook and some of their smart watches and Microsoft and others. They do they're also an ODM, very, very talented. They're based in Taiwan. And we're working with them. This is public knowledge. We're working with them on developing a reference design for AR glasses. We're still talking to them about use case. Now we are hardware. We're doing all the hardware. We're trying to figure out, what do we do with this stuff? So there's opportunity to partner. We do have partners at various levels. We have partners in Europe as well, depending on what technology you're talking about. But the answer is yes. Short answer is yes. Quite a bit of work out of Asia. We have, most of the manufacturing, as you know very well, in the world, and the product assembly is done in Asia. So.
When the iPhone came out, there was no app store. And you might argue successfully right now that the app store is what made the iPhone. There's so many things that you can do with it now because of that, because of all those independent developers. And one of the things that strikes me about these AR glasses is that if you could harness that same sort of development spirit with a basic set of glasses, you might come out with a lot of interesting use cases. You might come out with a lot more demand for this product. And so what I'm thinking is, if someone wanted to crowdsource a set of basic glasses and then, have like an app store for that and allow people to develop apps for it, how difficult would that be? And how costly would it be to come up with some crowdfunded set of glasses that people could play with?
Good question. I got to think a second. So these things are, because they're such low volume. Okay, so let's step back. There are a lot of companies building glasses today, right? That they've announced at various levels. XReality, the one that comes to mind right out of Taiwan. There's a company called Music of America. There's a bunch of companies doing it. They usually sell for a lot of money, right? $1,000 or there, right? That range. And the reason, so the short answer is they can be done because the volume is so low. Generally, the piece part cost is very high, obviously. The thing to think about, and this was how to think about Jim. The thing to think about here is that it's not the hardware that's the hard part. The question is, what is the platform to develop the apps on? That's the point. I don't have a good feel for that. That's why.
Could you do it on something like the iPhones or Android phones?
I suppose you could. iPhone is a bit more difficult. iOS more closed. I guess you can. Android is much easier, certainly, right? Because it's a much more open platform. It is open platform, to say, right? Yeah. Open ecosystem, whereas iOS is not, and the other rules. But it certainly can be done. I guess the question is, how to think about it. It's a good question. Where does the apps run? If it's in the phone and connected to this, is that how it works? But then, I guess the question I would have to ask, if you have an app for the glasses, you'd want to be self-contained, right? You want to do stuff in the glasses. Then the question is, how do I interact? So then how do I interact with this stuff? Is everything by voice? Do I say, Alexa, do this, or glasses, do this, or do that, move left, move right? What are the modalities I need to have set up? What modalities need to be set up at a very minimum for developers to develop something interesting? Like
what I'm thinking is perhaps the guiding principle in this particular case would be to minimize costs. Mm-hmm. So whatever you could do to minimize costs, whether it involves offloading, processing, or whatever you would need to do.
Right, we can do all that. Again, the question I asked, okay, let's do a thought experiment here for a second. I want to do an app. So some guy, girl, whatever, some person is developing apps somewhere. It's great. They got this device. You remember, with the cell phone here, you've got some modalities here. You've got the ability to double tap, ability to swipe left, swipe right, what have you, change the zoom and everything else, for example. And that allows you to do a lot of these applications. The applications really work around that interactive modality. And the same way here is we have to define what are those modalities of interaction needed at a minimum, so that whenever somebody else's apps, they can have a way to have the user interact with the application. Does that make
Yeah.
sense?
Right.
That's the part I don't know. That's why I'm saying, what is that? Do I snap my fingers?
I
Do
think
I do this? No, I don't know the answers, right?
I'll jump in real quick
Yeah,
and
sure.
say that I just want a mouse pad out of the phone, so that I don't have to look down, and as I move my finger across the display, then that changes the focal point in the glasses. And if I click on the display on the phone, then I'm selecting something in the glasses.
Yeah.
So
Well-
defining my focal point, or defining my field, field of interest, or whatever.
And
That's-
I
that's all.
think this is one of the things that can be left to the creativity of the app developers.
It can be, but we said, but the thing is, we have to implement that in hardware, right? So for example, in the case of Michael's example, in terms of having a mouse pad of some kind, the company called North had something called a ring, right? Basically had a joystick, a little ring that you wear, and then you can just have a tiny little joystick on it, right? And a push button, so you can do that. But whatever it is, Jim, you have to create that Bluetooth connection with the device, and you have to be able to then move the pointer around in your field of vision. So it can be done. And so the app developer can help that, say, hey, it doesn't work for me, get something else. But they got to start with something, right? That's really my point. So what's a starting point? It could be a touchpad. Maybe you put a little touchpad right here in the temple of the glasses, right? I can move around. I'm just making stuff, not making up, I'm just giving you ideas, right? So you can scroll around like a touchpad, and double tap, triple tap, single tap, right? Potentially. Or do Michael's thing, have a little pad here. I can move around. You can't see me. Like here in my hand, I have a pad.
Yeah. So the thing
That's what
about Jim's idea is kind of like a Raspberry Pi for glasses, right?
Yes.
Yeah.
Yes.
Yeah.
So like, yep.
The thing that the Raspberry Pi relies on is that it has a standard OS in it, and you can hack on the OS, but it's already got a very powerful software base that you can use to do a lot of things. And I don't know that these glasses have that kind of software capability yet. So.
Nope. No, I love Jim. I love the idea. Let me think about. I love the idea. I got to think about how to do the final mile, if you will, right? I love that. I think Michael, I agree with you. Raspberry Pi equivalent, whatever it means. That's the easy part. All this is not hard, actually. That's the good news. It's really not hard. It's engineering, right? More than development. And it's straightforward. It's something you can buy relatively off the shelf. You can buy pads and touch pads and all that kind of stuff, right? And then you can figure out, get Bluetooth touch pads, and it's the Bluetooth signal very easily, and then integrated Bluetooth receiver, and then so on, right? That can be done. So absolutely. The answer is yes. Anything about. I love the idea. I'm just thinking that you guys creating a lot of interesting conversation. I got to think it through. But I love to be able to do that. That's another way of doing it. You're right. We can do it with the industrial domain, which we will do anyway, but to get in the hand of hobbyists and just sort of, the myriad of developers around the world like to, who like to fool around this kind of stuff. That could be interesting. I like the idea.
How low do you think you could drive the cost for something like that?
That I don't know. I mean, that is a good question. I mean, the glasses themselves will, I'm going to guess, again, it's hard to tell because it's all based on volume and everything else, but it won't be cheap, right? You're talking about, it won't be HoloLens, like, it probably just, I'm speaking as a private citizen, not for my company now, but probably somewhere in the $500 to $1,000 range, anywhere in between that, right? This depends. Is where the glasses will be, I think, as low as 500, as high as 1,000, in that range. And then for the Raspberry Pi equivalent interface, I can't cost that much more. I can't imagine that. No, I can't imagine that'd be more than 100 or 200 bucks, right? Again, I'm just making stuff up here, but to give you order of magnitude, that's where I think it will be. Let's say in that order of magnitude, right? The whole system, right? Would be
Well,
in that range, I would think.
one thing that comes to mind is it's been said, I don't know if it's true, that Meta loses money on every Oculus Quest 2 that they sell, that they're
Sure.
essentially subsidizing the
Course.
cost of the units. And I wonder if you had a company come in who had an interest in this, who was willing to subsidize part of that cost,
Sure.
maybe it could drive prices down to the point where it would end up in the hands of hobbyists.
Yeah. No, for sure. I mean, clearly, you know, if you have a Godfather somewhere, it'd be great, right? A sponsor, it'd be wonderful. I think it'll work. You know, you're absolutely right. I mean, Meta, Facebook is doing this because they want to sell content in the Oculus store, right? Very simple.
Right.
You know,
Right.
pure and simple. They want to get eyeballs. You know, that's so they're making money. So yeah, they're losing money potentially on it. So they say publicly, but I'm sure they're doing quite well on the other side, right?
Yeah, yeah.
You know, but yeah, your point's well taken though. You know.
Yeah, this is ET, Emily. They call me ET. Okay.
Oh, okay.
I've been doing business models here in Silicon Valley for a long time, and the price point for augmented workforce is astronomical. And then you put it into something like healthcare or firefighting or military, and almost the sky's the limit. When you say, I can't buy $1,000 pair of glasses for my kid, but I can buy that for a soldier or an OR surgeon, you know, then that's a different ROI. So I think because these major players are getting into healthcare and are, you know, looking at the G5 solutions and this virtual reality, physical reality stuff, that it's coming. And they, you know, developers like you guys don't grow on trees. So they're going to woo you to jump in with grants, you know, job offers, spin-offs of companies to do this stuff. So I just think that it's going to happen. We don't necessarily have to go the consumer route, that the apps that already exist will be reinvented into this new technology. So, you know, I would love to have everybody and their mother working on it like they do with games, but again, for the reasons that you mentioned, and also the supply chain, you know, with the Russians and the semiconductor business quandary, how they're going to make enough chips next year, that's going to be a showstopper. So I think we should focus on where we're at and modify and, you know, rework those applications rather than just throw a bunch of new stuff out there and then everybody's waiting for an order to get processed. I do believe in Kickstarter and crowdfunding. A lot of people, you know, prefer to do that nowadays. And if you go and squint and look at some of these funding sources, there's all kinds of optical devices and wearables that people are touting. Maybe reinvent some of those, I don't know. But I really think because of the expense, because of the limitations and the economics and the human resources, creative people to write the code, it's going to stay more in the enterprise level.
That's cool. Hey, I have one last question for you.
Sure.
With a blue sky kind of thing. My wife and I are getting older, and we're looking at these replacement lenses for our eyes to take care of our vision and, you know, deal with cataracts or whatever. And the lenses are easily inserted into your eye, and they're very easy to replace if you need to, you know. So I'm just wondering if you had access to that additional real estate, some sort of active lens where it was cooperating with the glasses. What would that be like? What would it enable you that you couldn't do today? Because I'd be happy to put in, you know, augmented lenses instead of just regular lenses if it got me something really cool, you know.
You don't mean lens of the eye. You mean the physical lens of the glasses, right?
No, the lens of the eye. Yes. Yeah, so
okay.
Right now,
So
we have to replace them in order to get rid of cataracts, whatever.
Okay. So there are several approaches. One, it's, there's a company, this public again, it's called Mojo Vision out of Bay Area. And they have contact lens with a display embedded in it and other things, right? That they say could be ready. I think they forecast 2030 to do, again, literally to do Iron Man or that kind of stuff, right? Where you can see things. But here's the thing. When you have, from an ophthalmological point of view, when you have cataracts, when you have lens deformations, when you have age-related macular degeneration, all those kind of things, a lens won't help you, right? Actually, it just won't help you at all, because light has to go through your lenses and through your cornea and through other optical elements before it's your retina, where you actually sense the signal. At the end of the day, the retina is where the signal matters, right? At the end. So the approach that, one approach has been really exciting for a number of years. And again, my colleague, ex-colleague, my friend, Nikhil mentioned earlier on a previous chart, he worked for a company, and actually back in the 1990s, this was done out of the University of Washington, where they used a scheme called direct retinal scanning. And direct retinal scanning uses laser beam scanning, basically, and it goes directly into, rather than having a secondary image plane where you have a virtual image out in space created through some lensing effects, you take the beam of light directly into your retina and you paint your retina back in the front, scan your retina. And so the advantage of that approach is several-fold. It's a good approach because if you have lens issues, if you have cataracts, if you have AMD, age-related macular degeneration, it's all invariant, because as long as your retina is good, that's a key, right? If your retina is bad, then all bets are off, of course, right? That's a bad thing anyway. So if you don't have detached retina or anything else, your retina is good, then guess what? No matter how bad your eyes are, you can still see that image, right? And that's the cool thing. So that's the future. That's my blue skies. I'm thinking about how do you, and that's already been proven, but it's not new. This is just back down in the 90s. This Israeli company who's no longer in existence, called Eye Vision, did that. I was working with some doctors in Israel many years ago trying to do that for AMD, basically for patients so they can read and so on and so forth. So that's probably the ideal way, is to go to a direct retinal scanning system, which then really obviates a need for any kind of glasses correction, and it can handle most of the deformities of the eye, whether it's age-related or not. Okay.
Cool. Thank you.
Cool. Anybody else? Anything else? Any other closing thoughts?
I think Jim, you muted something.
Yeah, I know that when some of the SPIE conferences that I went to, I don't know, 5 years ago or so, people were talking about developing displays for like tablets and so forth that would actually correct your vision better than glasses could. And these were usually multi-layer displays where they were stacking one display on top of another and doing various optical gymnastics to try to get that. Now, you're not really doing that.
No.
I don't know if something like that could be layered in the glasses or not. But anyways, that's one other thing that I've seen. I suppose this is a weird way to do it, but I suppose that if you had a camera that was feeding this tablet that had one of these displays that could correct your vision better than glasses, if you had a camera in a pendant or something, then you could, look at the tablet and see the world better than how you currently see it. But
Yeah.
anyways, that's just a technology that was there. I wanted to say I still believe in the crowdfunding.
Yeah, that's
idea.
absolutely should. I mean, nothing wrong with it, right? It's just a question of how do you get there? I mean, absolutely. Yeah, I have, it's really a question of how do you get from here to there, right? That's the thing. There's complexity there. It can be done. I guess of course, who's going to fund it? Who's going to do the work? Even if you get let's just take a crowdfunder. Let's say you get $1 million. That's for argument's sake. Hard like whatever. Just n number of dollars doesn't matter. The money. You still have to find somebody to go do all the work. That's the thing, right?
Right.
Hey, Jim, I vote that all of those fools that are buying Metaverse real estate invest in your idea.
That's right. There you go.
Exactly.
go.
And you sell a bunch of NFTs and retire next year,
Yeah, exactly. Yeah, I still haven't bought any crypto yet. My son's bought crypto, but I haven't bought any crypto. I'm like, you know what? I'll keep a gold bar somewhere just in case, but in any case. But no, it's just, yeah. So the SPI, just a quick comment on that. So I think the way those things work is probably they pre-distort the image to look at the eye distortion to invert it so you see it properly. That's what I think it does. That's not very compelling. I mean, direct retinal scan obviates the need for anything, right? Other than you have to have a good retina. If you have
Yeah,
good
that
retina,
bypasses all the optics. Yeah.
you bypass all the optics. That's the way to do it, right? Everything else is just yeah, I see, to use your words, optical gymnastics and all. It's fraught with issues and fraught with, be fraught with distortion and this and that and all kinds of stuff, right? Just keep
Yeah.
it clean. Direct retinal scan, it works. I've seen it. It's doable. It's just a form factor issue. I think we'll get there. But that is really, so that's a blue sky to the future. That's where I want to go. Once you do that, then it's all golden, particularly for eyesight, as you get older and everything else as well. Even AMD, because AMD is terrible, right? Macular degeneration for people. It's really, really tough. So that's a really awful disease. So cool. Good guys. Anything else?
Thank
Anybody?
you so much, guys. I got to take off, but thank you very much, Bharat.
Hey guys, great discussion.
How can we contact you or learn more about your organization, the LaSAR Alliance?
Yeah, Dominic, just go ahead. You can feel free to share my work email with them, right?
Yeah,
Email.
sure.
Feel free to reach out to me. I'd love to chat with you guys, and brainstorm. Sure, absolutely.
All right,
Absolutely.
thank you. Appreciate your
Thank-
help.
Thank you all. Hey guys, thanks a lot. Great
Thanks a
conversation.
lot, Bharat. Thanks a lot.
Thank you. Thank you all. I appreciate it. You guys have a great day now.
Bye-bye.
Thank you. Bye now.